We have just finished talking about erosional features of glaciers. Now we're going to talk about a few depositional features, and one that you've already come across is the word moraine. Moraine is, there's a whole bunch of different types of moraine, but all of them are unsorted, unlayered piles of till. And till is just sediment that is sometimes angular, sometimes subbed round, depending on where it is within the glacier. There are many types of moraines. Lateral moraines are on the either side of the glacier. Medial moraines are when two valley glaciers come together. They join and you'll get a medial moraine in between. The most important moraine that you need to know is called the terminal or end moraine. Marks the farthest advance of the glacier. And then we have one called a recessional moraine. These two moraines, terminal and recessional, are both things that occurred on Long Island. The glacier retreats, and then it pauses and deposits material. It could stay there for 1,000 years, and it will always, this recessional moraine will always be parallel to the terminal moraine. We will be talking about that on a later slide. I do like you to listen to this man. He talks about glacial till. It kind of looks like my beach area, which is so different from your beach area. He is going to talk about an erratic, and I will be talking about that when we get to the 5th slide. On this slide talks about a terminal moraine, and I'm going to hit this so that you can see this. This is a glacier that's standing still, but notice that material is still being dropped. Now please don't mistake that this glacier is defying gravity and moving uphill. It is not. It's just melting back. So here you have the terminal moraine, but when it moved back, it developed a recessional moraine. And this sign is kind of pointing out, here's my terminal, and here would be lateral moraine, here would be the medial moraine. This is just showing you wherever the glacier melted, it drops. When the energy decreases, material gets deposited. It would be a type of question that you would get. Materials that are sorted are typically being deposited by water, but glaciers can't organize. They just drop everything where it is, wherever it melts. So the correct answer, hopefully you can see, is D. An erratic is also evidence of glacier erosion from more than likely where the glacier originated, and deposition where it drops it off. It carried it within the glacier. Erratics can be huge or they can be small, but they never ever match the bedrock beneath it. So it could be a huge, and I'm going to show you some pictures of huge boulders that can only have been brought by a glacier. Water can't pick these things up. This is Mrs. Kelly's husband. He is making a joke like he's picking up this glacier. But notice how big this boulder is, and it's in between the trees. The man on the side, you can listen to this because he talks about how it's different. And then I'm going to show you some other pictures with a question. So listen to that. As many of you know, Mrs. Kelly loves to ride horses, and this is her horse named Eli. And she is riding out east, and she's putting her horse on a glacial erratic. So they're just standing on it. It doesn't match the bedrock beneath it. This picture should be familiar. It was Mr. Kelly looking, trying to hold up this glacier. And this is a Regents question. What is the best evidence that a glacial erratic has been transported? Well, here's the diagram. Is it located at a high elevation in a mountainous area? There's nothing about that diagram that shows you that where it is. Can you measure something? No, you're not given a little measuring device on this picture. Is its composition different from that of the bedrock beneath it? That's your correct answer, because it is. And you don't know what intensely metamorphosed rocks are, but that is not showing that. This is another typical question about glaciers. They're showing you a mountain glacier, they're showing you here is your plucking and your abrasion, and this is showing you the terminal moraine. And wherever meltwater is, then it will gradually be deposited in the lake. But they're asking you what evidence could be found on the surface of the bedrock. So you could have any type of unsorted sediment just being deposited. You could have striations. You could have grooves on the bedrock showing you that a glacier was once there. We've just finished talking about mountain and valley glaciers, and we're going to now talk about the glacier that actually covered Long Island. It's a continental ice sheet glacier. There's only two places in the world that they exist at this point, Antarctica and Greenland. Continental ice sheet glaciers aren't nearly as picturesque and dramatic as valley glaciers are, because they're flowing over relatively flat lands. So you're going to get rounded hills, you're going to get lakes and swamps. The Great Lakes were formed by the last glacier that covered us, and we're also going to get a type of lake called a finger lake, and we're going to get something called a kettle lake. This is showing you the farthest extent of glaciation. I'm kind of going along the line where glaciers have existed. We saw this slide basically in the beginning of this glacier presentation. This little area by Jamestown was never covered by a glacier. If you go on Long Island, do you see where the Ronkonkoma moraine is? That's the farthest extent that the glacier has gone. That's the terminal moraine. This Harbor Hill moraine, which is in the North Shore, could be a recessional moraine, which most people think it is. Other people do think it could have been another glacial advance that just stopped there. But the Harbor Hill moraine does the North Fork, and the Ronkonkoma moraine does the South Fork. This area where Plain Edge Middle School is was not ever covered by a glacier. Mr. Organic in the beginning intro talked about how river valleys get changed into U-shaped valleys. We have 11 very long, very narrow, oriented north-south because the glacier came down from the north and traveled south. And they're very deep lakes that have very high walls and very U-shaped bottoms. Please look on page 3 of your ESRT to find the Finger Lakes. But what happened here is the terminal moraine dammed up the lakes. This is a pretty wordy slide, but it's showing you how the V shape got turned into a U shape that was a former river valley. The erosion deepened the valley, and you have debris at both ends of the lake that are trapping any water that gets in there, and you'll eventually get water filling in the valleys, and the Finger Lakes resulted. As you can see, I've underlined U-shaped Finger Lakes due to erosion. We are going to be talking about another type of lake that is due to deposition, but these are due to erosion. They're very deep and they've been eroded away on the sides. So Finger Lakes are due to erosion. We are going to talk now about some of the depositional features. Moraines you're familiar with. Drumlins, I'm going to show you some pictures of them, but it's typically a shape that's almost oval, like an inverted spoon, and the steep side points in the direction from which the glacier came from. We're going to be talking about kettle lakes. We have a very large one around us called Lake Ronkonkoma, and I'm going to show you how that forms. And we're going to show you about an outwash plain. An outwash plain are made by the streams when glaciers melt. And because it goes into a stream, an outwash plain is always going to be sorted and layered. So when you look at this top diagram, this area has been covered by the glacier. Nothing there will be sorted or layered. But these are the meltwater streams. They're typically braided, they're called braided, but because they go into streams, it becomes sorted, rounded, and smoother. The bigger particles will get dropped here, and they will be gradually dropped smaller particles the farther away you get from the glacier. And because of this area, we call it an outwash plain. This area is covered by the glacier. An outwash plain has never been covered by the glacier. And as I said, Plain Edge Middle School was never covered by the glacier. The farthest advance of the ice is typically around where the Long Island Expressway is. This is an example of a braided stream. They can form outwash plains because the sediment drops when the energy becomes less. So this is the terminal moraine, farthest advance of the glacier. The outwash plain is always in front of it. That's where it forms from meltwater. Plain Edge Middle School is in an outwash plain. I'm showing you a picture of a kettle lake, and the diagram here shows you how it's formed. This is Lake Ronkonkoma. It is not an erosional feature, it is a depositional feature, because you get a block of ice that gets dropped off when the glacier starts retreating. It eventually gets covered by the meltwater and depositing, and then it eventually, when the ice block melts, you'll get a glacier formation called a kettle lake. Please watch this little slideshow. So these are the steps in forming a kettle lake, because when it leaves behind that mass of dead ice, the meltwater deposits the sediment around it. Over time, the sediment builds up, and as the temperature increases, the ice melts and a small lake is formed. This is a typical question about a glacial feature. So you see the block of glacial ice in outwash, covered, and it leaves this lake. Now you might be tempted to say that this is a finger lake, but it is not, because that's not how Finger Lakes form. This is definitely a kettle lake.